Assalamu alaikum, dear students. Today we are going to solve this titration. It has been taken from May-June 2023, 507042. Aqueous ammonia is a solution of ammonia gas. As you know, aqueous ammonia, you are familiar with it. NH3 aqueous mean solution of ammonia gas in water, and when they react, they add it to each other, they make ammonium ion and hydroxide ion. That is why we call them alkali, because it provides hydroxide ion. So a student titrate two sample of aqueous ammonia A and B, 0.50 mole per dm cube of HCl, and A and B, with A and B the student does four titration, two with A and two with B. So you have to be very clear that you have to fill your burette. It is already written with HCl, whose concentration is 0.500 mole per dm cube, right? It is already given to you. Now, they described 6 steps here. Uh, in first step, they're talking about rinsing of burette and then adding HCl. So rinsing of burette is with HCl. You pass HCl through the burette, and then you fill your burette with HCl. You know why? Because if you wash it with water first and then add HCl, it will change its concentration, and definitely it will affect the uh, reading on the burette for the titration of A and B. Then you use pipette. This is pipette. Through pipette, you transfer fixed volume of A, which is 25 centimeter cube. And then before starting titration, you add your conical flask on a white tile, because you want to get clear color change, or for knowing your reaction is finished, you have to add indicator in it, which is methyl orange. And I know you already know that methyl orange in alkaline media is yellow in color. Okay. Now start the titration. Open the tap, add from the burette and swill the flask. At end point, slow down your titration, add drop by drop uh, from the burette into the conical flask to get the clear end point. Now repeat the titration at these 6 steps and take the titration results. Now they have given us these burettes, and initial and final reading. You need to read burette always from upside down, because you need to know the volume of um, liquid empties in a conical flask added to the conical flask, right? Not which is present in the burette. So initial burette reading is 0.0 and final burette reading is 15.2 here. Here initial burette reading is 15.2 and your titration end at 30.2. So these are the burette reading I have written already in the table. Now come to the second result, titration result with B, and they have provided us readings. For initial reading it is 0.6 and for final reading it is 35.5, and I have again filled this table again with these readings. Now explain why the student uses white tile. As you know, as you already know, to get clear color change at the endpoint. Okay. Now calculate the mean volume of 0.50 mole per dm cube of HCl needed to neutralize 25 centimeter. So you have to be very vigilant. See, for A, you have a table which is on the previous page. For B, you have a table which is given on this page. So please make sure you are using the same readings from the same tables. 15.2 plus 15.0 divided by 2 will give you mean volume of 15.1. 34.7 plus 34.9 divided by 2 will give you 34.8 reading. Now you have a calculation part. The equation for the reaction between HCl and aqueous ammonia is given here. Use the mean volume of acid to neutralize 25 centimeter cube of A and D to calculate the concentration of. So be very clear, what are you going to calculate in this part? So first of all, write what is your question. You need to calculate concentration of A, which is question mark, and you are provided with what? You are provided with concentration of HCl. You are provided by mean volume of HCl, which is for A, it is 15.1 and concentration of HCl is 0.500 mole per dm cube. And you are also provided by volume of A, which you have taken in a conical flask at the time of titration through pipette, that is 25 centimeter cube. So once you are clear about these things, you would be able to calculate. So, from these three things, we would be able to calculate the number of moles of HCl. So first thing first, we will calculate the number of moles of HCl to get the concentration of HCl. How? See, number of moles we need to find. Concentration 0.500 into volume is 15.1. Some student already convert it into dm cube, so there is no need to divide it 1000 when you convert it. Here I have written same, so you have to divide it with 1000, right? So what is the answer? You get answer 0.5 into 15.1 divided by 1000, and it is 7.5 into 10 raised to the power minus 3. 7.55 into 10 raised to power minus 3. These are the number of moles of what? HCl. So here we find number of moles of HCl. Now we can apply ratio method since they are 1:1 ratio. So we put 1 here, and for 7.55 into 10 raised to power minus 3, we will get the same number of moles. So now we will get the number of moles of ammonia, which are 7.55 into 10 raised to power minus 3. Now we will put these value n is equal to C into V. This time we have number of moles of ammonia and volume, and we can calculate the concentration. Number of moles 7.55 into 10 raised to power minus 3. C into volume is 25 centimeter cube. So again divided with 1000 and you get the answer 7.55 into 1000 divided by 25, and your concentration is 0.302 mole per dm cube. So this is your answer for the concentration of ammonia. Okay, now for this question, let me erase this part. Okay, for this question, see, calculate the volume of ammonia gas measured at room temperature and pressure RTP dissolved in 25 centimeter cube. So when they are talking about ammonia gas, you just need to use your molar gas volume, which states that at room temperature pressure, each gas occupies same number of moles, occupies same volume, that is 24 dm cube. So 24 dm cube occupied by 1 mole. So volume, It is very simple. Number of moles are, what are the number of moles? Take it from the previous. Here, you calculate the number of moles of ammonia. These are the number of moles of ammonia. So just put them here, 7.55 into 10 raised to power minus 3 into 24 dm cube. You get the volume of ammonia gas. So what is it? It is 7.55 into 10 raised to power minus 3 into 24 dm cube per mole, and you get 0.1812. Now coming to this part, and this part is the same part like you have solved previously in this place, right? You have to repeat the same procedure, but this time you have to take the mean volume for B. So you are given by HCl, and HCl concentration, which is 0.500 mole per dm cube, and the mean volume now this time changed. It is 34.8 because you are talking about B. So first thing first, N is equal to C into V. Find the number of moles of HCl. What are they? 0.500 into volume is 34.8 divided by 1000. And you will get 0.500 into 34.8 divided by 1000, and you get the answer, which is number of moles of HCl are 0.0174. Now you will apply unity method, ratio method from the equation HCl plus NH3 combined to form NH4Cl, and 1 mole is reacting with 1 mole, so 0.0174 with X. So you get the moles of ammonia, which are 0.174, and they are asking about volume in dm cube. They're just asking about volume in dm cube. So what is the formula? Volume is equal to N into 24 dm cube because they are talking about gas. So first you find the number of moles. Just apply here 0.0174 into 24, and you will get the volume. And the volume is 0.4176. You can also write 0.418. Answer should be of 3 significant figure. Now the student rinse burette with 0.50 mole per dm cube of HCl immediately before it is filled. Explain why the student should not rinse the burette with distilled water immediately before it is filled with 0.50 mole per dm cube. So you have to write it in 3 points. Number 1, if we wash the burette with distilled water, concentration will be changed. Washing it with water first will dilute will change the concentration, mean dilute it. Making it dilute, and further effect, if your acid become diluted, your A and B sample require more volume to neutralize. I hope you understand this point. Now suggest any why universal indicator